What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA A+ 220 1101 certification exam. So let's get into it. In this video, you're going to learn about mobile device network connectivity and application support, such as wireless cellular data networks, Bluetooth, location services, mobile device management, and mobile device synchronization. All right, so let's talk about some wireless cellular data networks such as 2G, 3G, 4G, and LTE. So any user of a mobile phone has used a 2G, 3G, 4G, 5G, or LTE network. This technology does not come from phones, but rather from the provider's cell tower. And the G stands for generation, and each new generation of network service provides advanced signaling and available services. And most cell phones that are in use now, they either support 3G, 4G, 5G, or 4G LTE. And here is a quick breakdown on the differences of each generation. So you have 2G. This was introduced in 1993. It uses what is called GSM, or the Global System for Mobile Communications. It uses a CDMA system, or a code division multiple access system. It supports narrowband internet service, supports data speeds up to 64 kilobits per second, uses digital signals instead of analog, and it has support for voice calls, SMS or short message services, and MMS or multimedia messages. So basically with these phones, all you could pretty much do back in the day is make a phone call and send a text message out. That was pretty much the extent of what you were able to do. Next, we have 3G, and this was introduced in 2001, and this also uses CDMA, or code division multiple access system. This supports broadband internet services. This supports data speeds up to 2 megabits per second. This provided high security and international roaming, and this supported video conferencing, mobile TVs, and GPS. So you can thank the advent of the iPhone when it first came out. This is the phone that really changed the game for 3G cellular technologies back in the day. Next, we have 4G, and this was introduced in 2009, and this uses LTE and WiMAX technology. And LTE, that stands for long-term evolution. Basically what LTE is, it means simply this. So even after 4G was widely available, there were many networks that were not up to the required speeds that were supported by 4G. So 4G LTE came about, and this is capable of delivering very fast and secure internet connections. So basically 4G is the predetermined standard for mobile network connections, and 4G LTE is the term that was given to the path which has to be followed to achieve those predetermined standards. In 4G, this also uses CDMA systems, or code division multiple access systems. It supports data speeds of 20 megabits per second or greater. It also has support for ultra broadband internet service, and it provides speed, high-speed handoffs, and global mobility, and it supports high-speed applications, mobile TV, and wearable devices. And then we have 5G, and this was introduced in 2018, and this uses a technology called MIMO, and that stands for multiple input, multiple output. It also supports data speeds of 100 plus megabits per second. It provides extremely high speeds and low latency, and it supports high resolution video streaming, remote control of vehicles, robots, and medical procedures. So basically, if you want to live in a world where you have driverless cars just driving themselves all over the city, well, 5G is supposedly what's going to be the technology that allows for that to happen. Next, let's talk about a hotspot. So Wi-Fi hotspots, these are internet access points that allow you to connect to a Wi-Fi network using your computer, smartphone, or another device while away from your home or office network. A hotspot, this is a blend of software, hardware, and network data services that combine to transform a phone into the equivalent of a broadband modem and router. So to rephrase, a mobile hotspot can distribute internet connectivity to nearby systems via a Wi-Fi signal. And the mobile device can generate a default password, which you can change so that other devices looking to connect can get access to the network to access the internet. Now, as a word of caution, you want to be mindful that some cellular providers will charge an additional fee if you turn your mobile device into a hotspot or if you use it for tethering. So you want to check with your mobile service provider for details, and keep in mind that the data usage of every device connected to a mobile hotspot is counted towards your total data allocation. So if you're not careful, using a mobile hotspot could cost you extra money in overages. Next, we have what is called the GSM, or the Global System for Mobile Communications. So the GSM, this is a standard developed by the European Telecommunication Standards Institute to describe the protocols for second generation digital cellular networks used by mobile devices such as mobile phones and tablets. Its main task was to develop a single consistent network for all of Europe and come up with a better and more efficient technical solution for wireless communication. The GSM standard operates on three different carrier frequencies. You have the 900 megahertz band, which was used by the original GSM system. You have the 1800 megahertz band, which was added to support the swelling numbers of subscribers. Then you have the 1900 megahertz frequency, which is mainly used in the US. And one of the main advantages of the GSM standard is the ability to roam and switch carriers by using individual mobile units if partner networks are located in their destination. Next, we have what is called Code Division Multiple Access, or CDMA. So CDMA, this is a digital cellular network standard that utilizes spread spectrum technology. This technology does not constrict bandwidths, digital signals, or frequencies, but spreads it over a fully available spectrum or across multiple channels via division. Thus, there is improved voice and data communication capability and a more secure and private line. Essentially, CDMA offers more airspace capacity than what is called TDMA, or Time Division Multiple Access based global system for mobile communications, or the GSM standard. And furthermore, CDMA, it uses less power. CDMA digital standard is a leading communication network standard in North America and also in parts of Asia. Then we have what is called the Preferred Roaming List, or a PRL. So the Preferred Roaming List, this is a database residing in a wireless device, primarily a CDMA device, such as a cell phone, that contains information used during the system and acquisition process. PRLs indicate which bands, subbands, and service provider identifiers will be scanned and in what order. Without a PRL, mobile devices may not be able to roam outside of their home service area, or they may not get service at all. All right, let's talk about Bluetooth. So Bluetooth, this began as a short-range, low-speed wireless network technology primarily designed to operate in peer-to-peer or ad hoc mode between PCs and other devices, such as printers, projectors, smartphones, mice, and keyboards. Before a Bluetooth device can work with your computer or mobile device, it has to be paired with the device. And by default, Bluetooth is usually disabled on Android devices, but is enabled on an iOS device, such as an iPad or an iPhone. And to connect the Bluetooth device to a mobile device, Bluetooth first needs to be enabled. Then the Bluetooth device needs to be synchronized to the mobile devices. This is also known as pairing or linking, and it sometimes requires the user to input a PIN code. And once synchronized, then the devices, they need to be connected to each other. All right, next let's talk about a location service known as GPS, or the Global Positioning System. So the Global Positioning System, which was originally called Navstar GPS, this is a satellite-based radio navigation system owned by the U.S. government and operated by the United States Space Force. It is one of the global navigation satellite systems that provides geolocation and time information to a GPS receiver anywhere on or near the Earth where there is an unobstructed line of sight to 4 or more GPS satellites. Standalone GPS devices such as a TomTom Go and a Garmin, they can provide turn-by-turn navigation in vehicles, and most smartphones come equipped with GPS apps such as Apple Maps, Google Maps, and Waze, to where standalone GPS units are not really needed unless a user wants a dedicated GPS unit with a larger screen and less distractions. On the downside to a standalone GPS device is the need to keep the maps updated. Map updates in a standalone GPS device are oftentimes a separate purchase, and the user typically has to keep up with the subscription fee as well. In GPS technology, it can be found in fitness trackers, sports apps, pet tracking collars, and in the medical mobile healthcare market. And the Internet of Things, this has allowed for GPS technology to become easily integrated into a variety of objects, such as tracking personal property such as cars and drones. And next, let's talk about mobile device management. So mobile device management, this is the administration of mobile devices such as smartphones, tablets, and laptops. Mobile device management is typically a deployment of a combination of on-device applications and configurations, corporate policies and certificates, and back-end infrastructure for the purpose of simplifying and enhancing the IT management of end-user devices. In modern corporate IT environments, the sheer number and diversity of managed devices and user behavior has motivated mobile device management solutions that allow the management of devices and users in a consistent and scalable way. The overall role of MDM is to increase device supportability and corporate functionality while maintaining some user flexibility. Many organizations administer devices and applications using MDM products and services, and MDM primarily deals with corporate data segregation, securing emails, securing corporate documents on devices, enforcing corporate policies, and integrating and managing mobile devices, including laptops and handhelds of various categories. And also mobile device management implementations, they may be either on-premise or cloud-based. And some of the core functions of mobile device management include the following. It ensures that diverse user equipment is configured to a consistent standard and supported set of applications, functions, or corporate policies. It allows for the updating of equipment, applications, functions, or policies in a scalable manner. It ensures that users use applications in a consistent and supportable manner. It ensures that equipment performs consistently. It monitors and tracks equipment such as location, status, ownership, and activity. And it allows for being able to efficiently diagnose and troubleshoot equipment remotely. The next we have mobile application management. So mobile application management, this describes the software and services responsible for provisioning and controlling access to internally developed and commercially available mobile apps used in business settings on both company provided and bring your own mobile device operating systems such as smartphones and tablets. Mobile application management provides granular controls at the application level, which enables system administration to manage and secure application data. Mobile application management differs from mobile device management, which focuses on controlling the entire device and requires that users enroll or register their device and install a service agent. All right, next let's talk about mobile device synchronization. So data synchronization, this is the process of establishing consistency amongst data from a source to a target data storage and vice versa, and the continuous harmonization of the data over time. It is fundamental to a wide variety of applications, including file synchronization and mobile device synchronization. And keeping things in sync means having the same information on your different devices, and synchronizing data from the cloud to the desktop or other devices is how information is continually updated. And the types of data that we synchronize are too numerous to list, but here are some of the examples of the type of data that can be synchronized. Everything from email to photos, calendars, contacts, and location data. And finally, let's talk about cloud-based synchronization real quick. So with cloud-based synchronization, apps on a mobile device, they send data to the cloud where it is downloaded by other mobile apps, by web browsers, or by programs running on Windows or Mac computers. And examples of providers that enable cloud-based synchronization include the following. You have Microsoft 365, Google Workspace, and Apple iCloud. Now, data that is synced via cloud-based synchronization is encrypted and is secured by username and passwords. Mutual authentication is used by each side of the connection to verify the identity to the other side. And if synchronization to a cloud application is interrupted, the problem can usually be resolved by simply closing and relaunching the application. All right, so that was my quick little class on mobile device network connectivity and application support, where we talked about concepts such as wireless and cellular data networks, Bluetooth, location services, mobile device management, and mobile device synchronization. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA A+ 220-1101 certification exam. And until next video, ladies and gentlemen, peace.